Hello, welcome to another math lesson, and today we're going to be learning about how to graph this. Oh no. Well, we are going to learn how to graph those, but that's everything we're going to graph thrown all on one graph right there. We're going to learn them individually. So I'm going to have this Desmos file for you, so that way you can access it and look at, let's see if we can open up the list here. These are all the functions that are graphed here. They're all rational functions. So there are all these fractional things, and they all have their unique characteristics. And yes, when you graph them all at once, I think it makes a pretty cool pattern there, but obviously it's also a very confusing one. So not only am I going to share this Desmos link with you so you can investigate it on the computer, but I'm also going to share with you this right here. These are those same graphs, and they're graphed individually. So I've got something like, I think it's like 16 of them here that are graphed. Now, what I want you to do with this, a lot of students look at just the basic rational function 1 over x, and they're a little confused about how we come up with that graph. The reason I'm giving you 16 here is that I want you to figure out the pattern that's going on. There are some exceptions to when we have asymptotes and when we don't. The first thing I want you to look at is go through each of them and note where the horizontal asymptote is. So pause the video, go through all of the graphs, and just write the equation of the horizontal asymptote. Do that first. All right, I've taken it that you have gone through and you've marked where the horizontal asymptotes are. You should have written this out as an equation of a line like y equals something. And you probably noticed that some of them did not have a horizontal asymptote. They have what we call a slant asymptote, and some of them had no asymptotes at all. So we're going to discuss all those things today, what makes them happen and what makes them not happen. So let's take a look at your answers here. Oops, not that one, this one right here. So this first one should have a horizontal asymptote at y equals 0. And then we've got the second one here having it at y equals 0 also, okay? And then we've got for number 3, y equals 2. And same thing for number 4 here, horizontal asymptote at y equals 2 as well. Number 5, we've got y equals 1 for our horizontal asymptote. That stands for horizontal asymptote, not just saying, ha, it's y equals 1. And over here, we've got y equals 0. That one looks cool. Look, it's got 2 verticals on it. We're going to discuss how to graph those later. But the horizontal one is at y equals 0. Right here, we've got one at y equals 1. And then y equals 1 right here as well. And number 8. Then number 9, you should have y equals 0. I want you to check out something here. Notice that the graph crosses the horizontal asymptote here. And so I always get a question every year. They're like, how can we cross the horizontal asymptote? I thought you couldn't cross an asymptote. Look at this one. Go back to number 6. It crosses right there as well. We're going to learn that, yes, you can cross a horizontal asymptote. It's the vertical ones that we can't cross. And just to kind of give you a hint up ahead, the horizontal asymptotes, we learn about those because it tells us what's going on with the end behavior. So we're going to learn that later on. I'm getting ahead of myself, though. Let's finish this out. So we've got number 10 is y equals 0. So was number 9. Number 11, it's y equals 1. And number 12, it's y equals 2. Then we get to these fun ones right here. Notice I said ha, and then nope, we don't have a horizontal asymptote there. This is what we call a slant asymptote. And I might save this one for another video so we don't make this video run too long. But that's a slant asymptote. We're going to talk about how to find those. Same thing here. Another slanted one right there. And then this one doesn't even have a horizontal or a slant asymptote. This one has what we call a hole in the graph. Number 16 has a hole in the graph also, but it also has a horizontal asymptote at y equals 1. So we've got all these funny different combinations, and the reason why I gave you these is because I want to give you different looks at how these rational functions can be graphed. And so the first thing we're doing is just investigating what makes a function have a horizontal asymptote, and when do we get these strange cases where there's slants or there are holes, okay? So if you don't already know, I'm going to give you a hint, and then I want you to go back and look at things. I want you to write out the degree of the numerator and the degree of the denominator on each one. So in this case, let's see, I'm going to pick, I'm always trying to run through all my markers evenly so they don't all dry up at different rates. Things math teachers think about, right? The degree of this numerator right here, remember, is that highest exponent. What is it? It's a 2. and the degree of the denominator is a 1. So I'm just going to go through each one and write out the degree of the numerator and the degree of the denominator, and we're going to look for a pattern there, okay? Pause the video and try that one out. All right, all set. So we've got, should have each one, the degree of the numerator over the degree of the denominator, because we're going to investigate what I want to know. Big hint here is what happens when the degrees are the same, what happens when the degree up top is bigger, and what happens when the degree up top is smaller. So I'm going to go through and look at each one of these and investigate them. So this one, degree of the numerator, notice there's no x up here. So that means that's the same thing as x raised to the 0 power. X to the 0 is 1. Same thing right here on number 2. This is like saying 5x to the 0. So the degree of that numerator is 0. All right? And so in this case, the degree of the numerator is less than the denominator, and we have a horizontal asymptote at y equals 0. This one, degree of the numerator is less than the denominator, and look, we got a horizontal asymptote of 0. Maybe we can start to make a little bit of a conjecture here. This one, degree of the numerator is less than the denominator, and remember, we're focused on, is this degree larger, equal to, or less than the denominator's degree? This one, though, it's not y equals 0, it's y equals 2. But if we were to take away this plus 2 right here, then it would be 0, wouldn't it? Because it was, let's take a look over that on Desmos. I'm going to go over here, and actually I need to turn off these graphs. There you go. I paused the recording real quickly to turn off all these graphs because I had them on from the beginning of the video. But this is the graph we're looking at right now. And the degree, yes, is less than the denominator, but the horizontal asymptote is not 0. But I've got this vertical transformation going on right here of plus 2. If I were to take that off, notice what happens. Now we've got a horizontal asymptote of 0. So yes, once again, degree up top is less than the denominator, and so we get a horizontal asymptote at 0, but the vertical shift here, plus 2, moves everything up 2, and so that's why that's showing there at y equals 2. Let's go back to this. Now we get one that, over here on number 4, where the degree up top is equal to the degree in the denominator. And notice what we get here. We get y equals 2. There's no vertical shift here like we had in the last one. So it wasn't originally like 0 and then got shifted up 2. So it's at 2 for a different reason, okay? We're going to come back to that. So here, these are the same. Let's write that out. And as we go through, we're going to look and see if there's a pattern that's going on when they're the same degree. So far, it looks like we can make a general statement, say if it's less than the denominator, it's going to be at y equals 0. But I want you to kind of investigate these on the other 12. Let's look at number 5. So number 5, they're the same again, right? What's going on? We have y equals 1. Well, that's not what we got on number 4, so there may not be a blanket statement on the last one. Like on the last one where we said y equals 0 if it's less than the denominator. Look at this one. The numerator's degree is less than the denominator's degree. Once again, we have y equals 0. I think that's enough to say, hey, we can probably write that down. And if you're saying that this doesn't look very mathematical as far as a proof goes, looking at a few specific examples, there are ways that we can show that this is going to work out, and I'll explain that maybe in another video. But right now, if we can say we've got rational functions, and we are talking about the horizontal asymptotes, all right? I'll just abbreviate HA. If the degree, so we got degree of numerator is less than degree of denominator, then our HA is at y equals 0. All right? So that's our first thing that we can notice there. So let's keep going on and see what happens when they're the same and see what happens when we've got something else going on. The one up top is bigger. So looking at this, we've got another one right here that is the same. This is number 7. And notice we got y equals 1. Here's one that is the same. and we have y equals 1. So it almost looks like y equals 1 is what we're going to get when they're the same. The only thing is, if we go back to number 3, no, not number 3, number 4, they were the same and we have y equals 2. There's no vertical shift here, so something else is going on besides just y equals 1. We need to see some more examples here. Let's look at, see, the last one was number 8. Let's look at number 9 here. This is less than, and if it still follows the rule that we came up with, y equals 0 when the degree up top is less than the degree in the denominator. Look at this one over here. Less than up top, and we got y equals 0 again. So that still follows our rule. Here we've got another one that's the same, and we got y equals 1. Here we've got one that is the same, and we got y equals 2. So there's another one with 2 when they're the same. So sometimes it's 1, sometimes it's 2. Something's going on there. I know what's going on, but I'm the teacher, so that doesn't really help you out any, right? And then we've got this one. Now notice the degree up top is bigger than the degree in the bottom. So far we've covered when it's less than, and when it's less than, we know that the horizontal asymptote is at y equals 0. We've covered when it's equal, and we haven't really said the rule for that yet, but we said when they're equal, something else is going on. And then we've got this situation right here. Nope, not when it's, camera's turned off. There we go. We've got this situation right here where it's greater than. Now, when it's greater than, we've got this weird slant asymptote, right? Same thing over here. Notice, once again, it's greater than, and we have a slant asymptote. And then lastly, it's greater than, and we don't have a slant asymptote, we've actually got a line. It's not even a rational function. This thing actually reduces to a line with a hole in it. We're going to discuss these 3 in the next video, where we can say, what's going on here, what gives me the slant asymptote, what gives me the line with the hole in it, and figure those out. I don't want to make the video too long, so we're just focused on a couple of things today. And so let's go back. Oh, we got one more here. Once again, they're the same, and we get y equals 1. So I want you to think about it. What do you think's going on, or maybe you remember from like Algebra 2 class, that is making the horizontal asymptote here when they're the same? All right, I take it that you maybe have paused it, looked these over. We're going to discuss it now, and it all has to deal with the ratio of the coefficients. So these that are the same, go through real fast, and let's just write out what is the coefficient, or just circle the coefficients. This one is 1 over 1, right? That's your coefficients to those things. Where else do we have the same? We marked them the same. This one has coefficients of 1 and 1, so it's 1 over 1, which equals 1. This one has coefficients of 2, it's written there, and 1, which gives me 2 over 1. What's 2 over 1 equal to? 2, right? And let's see, another one that's the same. Let's find it. This one, the coefficients are going to be 2 over 1, which equals 2. Again, that's not the same, nor are those. And then go back to this page right here. This is number 5, number 7, and number 8. All had those sames written in there. This one, the coefficients are 1 over 1, which equals 1. Boom. This one below it, we've got the ratio of the coefficients is 1 over 1, which equals 1. This one, the ratio of the coefficients is 1 over 1, which equals 1. Now, everything I've given you is 1s and 2s. That's your ratios. Let's look at one, say, let's go over to Desmos, and let's type in a new one, just to kind of, verify that this is working. So look at E here. So I've labeled it to E of x. On your worksheet, it's not labeled that, but in Desmos, it's helpful sometimes to call the functions different things besides f of x. So here's one where the ratios are the same. Or sorry, not the ratios, the degree of the function, the degree of the numerator and the degree of the denominator are the same. And so we're looking at the ratio of the coefficients. Right now it's 1 over 1, so we should have a horizontal asymptote at 1. Hello, let's zoom this. Let's go back to the home screen here. Yeah, I don't know what's going on with that. I think it's because I labeled E. Let's call it F. There we go. It gets confused when I say E in there. It thinks it's the number E. So there we go. Now we've got this, and we've got a horizontal asymptote at y equals 1. So with that being said, let's change this around and make the number 5 here. Notice that, once again, the degree of the numerator and degree of the denominator are the same, and the ratio of the coefficients are 5/1, which equals 5. So our horizontal asymptote is at 5. What if I had something like 2/3? So 2 in the numerator for a coefficient, or the leading coefficient, and 3 in the denominator. Look at where the horizontal asymptote is now. It is at 2/3. If you can see or not, but right here is where 1 is. And if you were to graph, let's go ahead and do that. Let's graph y equals 2/3. And you can see that that horizontal asymptote is right there at 2/3. So it's always that ratio right there. When the degree of the numerator and the denominator are the same, you take the ratio of the coefficients. That sounds like something we should write down. So let's write it down. So I'm going to come back and say, all right, still talking about rational functions and the horizontal asymptotes. When the degree of numerator is equal to the degree of the denominator, then we're going to take, we'll just say the horizontal asymptote is at y equals the leading coefficient of the numerator, leading coefficient of numerator, over the leading coefficient of the denominator. I should probably type this out. That's kind of going to fall off the page there. So leading coefficient of the numerator over the leading coefficient of the denominator. So if you want to write an example in here, we could have x squared plus 3x all over 3x squared minus 4. And so if you were to graph this, check it out. The degree of the numerator is 2. The degree of the denominator is 2. That means degree of the numerator equals the degree of the denominator. So I should have the leading coefficient, the coefficient of that highest term there, which is 1 in this case, over the leading coefficient of the denominator. That means we're going to have a horizontal asymptote at y equals 1/3. All right. That's assuming that, well, no, that's going to be it, 1/3 there. Let's take a look. Let's actually graph that one. So I just made that one up off the top of my head. Let's check it out and make sure that it works for that. So I've got x squared plus 3x. And I want to divide that whole thing by 3x squared minus 4. So doesn't that look fun? And just to test it out, I said that it would be at 1/3. Let's put in y equals 1/3. Nope, not 1/2, 1/3. There you go. It's going through beautifully there. Now remember, it's okay to cross the horizontal asymptote. The horizontal asymptote is telling me what's going off as x approaches negative infinity, y is approaching 1/3. As x approaches positive infinity, y approaches, the y value is going towards 1/3. All right. We'll get into more of that later, but it really does become helpful when you're doing a few calculus problems out there. So that tells us horizontal asymptotes. Okay. Those are our rules for that. If the degree up top is less than the bottom, horizontal asymptote at y equals 0, assuming no transformations up and down. If they're equal, top matches the bottom degree-wise, you take the ratio of the coefficients. There's your horizontal asymptote. If it's greater than up top, that's going to be in the next video when we start talking about slant asymptotes and holes in the graphs, okay? But that's your video right now for horizontal asymptotes. We're going to do another one on the slants and the holes, and then we're going to do one on vertical asymptotes as well, okay? Thanks for watching.